I'm Gagandeep Kaur from Total Telecom. Today I'm joined by Mr. Renato Lombardi, Vice President of Huawei's microwaves product line, and we will be discussing the changing trends in the microwave industry and the impact of ETSI's new KPIs on the microwave industry. So my first question is that the work item in the ETSI millimeter ISG microwave backhaul new KPIs has drawn a lot of attention. What is the major driver and goals for this project?
Thank you for the question. The ISG, that stands for Industry Specification Group, was born in early 2015 as an industry sort of alliance within the context of ETSI, so using the ETSI platform. At the very beginning was in order to give confidence to the operator about using millimeter wave, E-band specifically. And then step by step, we enlarged the scope of work of the ISG mWT, millimeter wave transmission, covering all the frequency bands, what we call traditional micro frequency bands up to the millimeter wave, and also networking aspects. In this year, so was not only working on promoting E-band, so 71 to 86 gigahertz as the most reasonable, or from TCO point of view, or most affordable transmission media for wireless backhaul, especially going towards 5G and beyond. But we started working also on considering what has been changing in the last years, moving from SDH, so pure TDM systems, to full packets. And secondly, what was happening in this increase of capacity for the backhaul, so for downlink, uplink, mainly coming from new services with 4G and 5G later. So these new services and the fact that it is based on full IP networks led us to consider whether we had also to change the way how to evaluate the performance and availability of wireless backhaul, especially for the backhaul networks for the mobile operators, in a way that we could avoid over-engineering. So very often the requirements in terms of availability is so tight that can lead to over-engineer the links. And over-engineering means higher costs for the operators. That's clear. So we basically moved on one main path that was to no longer seeing backhaul as a segment by itself, but to see the backhaul together with the radio access network. So the first point was to move from a concept of availability of a capacity with the concept of availability of traffic. So the reason why we speak of availability for a micro millimeter wave link is that this propagation of radio waves, those frequencies, is affected by rain, especially when we have stormy weather and so on. And we have to engineer the link in order to withstand certain fading coming from rain. So microwave has a certain availability for different type of modulation. So moving from capacity to traffic, we wanted not just to speak of availability of a certain capacity as it is, but we wanted to link the probability of microwave to be available together with the probability that the base station is requiring a certain capacity. My first question that I normally put to CTOs or even my colleagues in ETSI is why do we need to give 99.9% of availability of a capacity when the base station requires that capacity for 0.1% of the time? So this leads to over-engineering. And that's what we created, a new matrix that we call BTA, that stands for backhaul traffic availability. The second step in this direction, in order to put together wireless backhaul and the wireless access, so the radio access part, was also to consider what levels of availability we need to give, not just for the wireless backhaul segment itself, but looking at the end-to-end quality of experience of the end users. So we used a lot of 5G RAN simulators, inserting the models of the backhaul. And this was a very good industry work because also other vendors and operators participated. And in order to find this new KPI. And these new KPIs, or key performance indicators for the wireless backhaul, give in the direction to avoid over-engineering, as said by looking not at the segment of backhaul by itself, but looking at optimized performance of backhaul plus radio access network, and looking at what really matters, that is the quality of experience of the end users. And that was a long work, 2 years, because it's a sort of revolutionary approach with respect to what we do today. So this will also impact the planning rules, partly the planning tools, but especially the mindset, and maybe also the organizations by the operators, in which this KPI will not be just coming from radio to backhaul, but it will be KPI that takes into account the overall network end-to-end. And we have seen with some simulations, which we have full confidence that this means even double the op length, especially for the millimeter wave. And this could be an incredible cost advantage for the operators, because the possibility to transmit multi-gigabits over E-band is definitely much lower cost, not only in terms of hardware, but in really total cost of ownership, especially the cost of the spectrum going in the millimeter wave range is much lower than in lower frequencies. So that's the spirit. It's been a very good work. I said nearly 2 years of work as an industry, and we published the group report and the related presentation 3 weeks ago. So it's still fresh from print, let me say.
Thank you. What's the major philosophy behind it, and what's the benefit for the operators?
Yeah, I said that the major benefit definitely for the operator is possibility to lower the total cost of ownership. So the requirements of traffic needed by 5G and the future by a 5G more mature, so in which they will have many more users, subscribers, and new services, requires a very, very high increase of capacity, so let's say tenfold or even more. So, and the lower cost way to transmit more capacity is always to use more spectrum. There are limits on what we can do in improving spectrum efficiency, especially in terms of cost. So that means that we need to go to higher frequencies. Higher frequencies are affected by rain in terms of off-lengths. So the use of new KPI will permit operators to have much lower total cost of ownership for the backhaul. And the major philosophy, I think, is useful to emphasize, to repeat, is not looking at microwave as a segregated or isolated piece of the network, but to see it as part of an end-to-end network. So wireless backhaul plus the connection of the base station to the end user, and look at the quality of experience of the end user.
Besides new KPIs, could you share the major trends and progress for another very important microwave topic, spectrum?
Yes, definitely. said the right word, so the last one, spectrum. So since we are talking of wireless, spectrum is definitely a resource that we have to value as much as possible. We needed to increase capacity in order to cope with the increase of traffic requirements by the base stations, by the 5G, 5G advanced. So what we have to do is to push the use of or finding new spectrum where spectrum is not used today. So what we are doing is we started working already a few years ago. Now really going much deeper is in the usage of the frequency bands above 90 gigahertz. So this is what we call W band and D band, that are two frequency bands that altogether can permit using more than 50 gigahertz of spectrum. This will permit allocate huge capacity in one single channel. And this could also lead to potential applications, not only for the backhaul, but for the front haul itself. So front haul is what is needed if the operators want to deploy a different type of RAN architecture, what we call a centralized architecture. So with a separation between baseband processing and the radio elements in a way that this could also lead to lower operational costs for the operators, especially in terms of power consumptions, renting of sites, implementation of mobile edge computing. So a lot of things that could really benefit. One of the key challenge for front haul is the dramatic increase of capacity, and that's why it is very important to work both on the technology, on standardization, on how to use a spectrum for these bands above 90 gigahertz. When we go, let me say, about 90, about 100 gigahertz, we start calling them sub-terahertz. So terahertz, properly speaking, starts at 300 gigahertz, so we call them sub-terahertz. And of course, the off-length gets shorter, but nevertheless, we think is definitely one of the most important trend. Not only I mentioned standardization of the products, how to use the spectrum. What is also quite important, we are working as industry trialing, especially D-band. So D-band means 140 to 175 gigahertz. So we are talking about very, very high frequencies. Is also to have accurate and reliable models for the propagation. These models are important because we can then translate these physical models of propagation in the atmosphere in planning tools, and the planning tools can be used by the operators in order to predict what performance and availability they can get from these hubs. So that's a lot of work we are doing. Another other important points is spectrum in general. So we call it a spectrum agenda, in the sense that it's not only to open new frequency bands, but it's also very important to make clear how is important to define proper licensing schemes and licensing fees. Otherwise, it will be too costly for the operators to deploy wireless backhaul and front haul. So that's why, for instance, we propose a formula that take into account the reusability of the channels. We are about to publish a white paper on these concepts, especially how to relate from the GDP, from the economical overall impacts of 5G, and how 5G is so tightly linked with spectrum cost. Not only spectrum cost for the radio part, we are always used to these very expensive auctions and so on, but also the cost of the spectrum for the backhaul. Many times wrongly, people think backhaul is done by fiber. Very often you can improperly listening to fiber to the antenna, but still today more than 70% of the base stations are connected wirelessly. So that's why it is very important to have not only proper spectrum in terms of quantity, but also spectrum priced in the proper way for the operators. So that's what we call spectrum agenda.